Hello and welcome my dear student. In this lecture, I am going to solve one of the interesting problem from the RC circuit, capacitor resistance circuit. So this is the problem where it has been given that there is a capacitor of capacitance C which is being initially charged with a potential difference of EY. Okay, so this is the capacitor which is being charged initially with a potential difference of E by 2, and there is another capacitor which is initially uncharged. So uncharged capacitance is 2C and charged capacitance is C. Now they are joined to form a closed circuit as shown in the figure. So these two capacitors are joined so that now it is being formed as a circuit. Now you are asked to calculate the current flowing through the circuit at time t equals to 0. So at time t equals to 0, only the first capacitor, this capacitor, will act as a battery. And since there is no capacitance in the 2C capacitor, so no charge is given. So that means it is acting as a plain wire. So for this second capacitor, can I say that this second capacitor is acting as a battery, keeping the polarity to be this side. So now the charge is basically C and potential difference is V by 2, E by 2. So this is acting as a external battery source which is equals to E by 2. And there is another primary battery is there, that is E, and which is connected with a resistance of R. And this 2C capacitance is not of use at t equals to 0. So I am joining this 2C capacitor with a plain wire, and this is the initial circuit. Now from this, what I can say that this E potential difference battery is supplying the current in this direction. E by 2 is opposing this, so ultimately the effective battery potential will be E minus E by 2, that is E by 2. Okay, so at t equals to 0, how much amount of current is being now flowing? So current I should be equals to how much? I should be equals to E by 2R. So this will be your answer, which is the current at time t equals to 0. Okay. So what is happening after that? After that, the capacitor, that is the C capacitance, which is initially charged, will gain the charge because of the supplied battery, and 2C will gain some amount of more charge. Okay. Now you are asked to calculate the second part of the problem is that the charge C as a function of time. Okay. So it is a case of purely unsteady state situation where some amount of charge is there inside the capacitor C and 2C also. Let us say initially the capacitor C has only charge, that is what is the charge inside this plate? So that is CE by 2. So if CE by 2 is the initial charge of the capacitor and initial charge of this capacitance is 0, so can I say that the total charge will also remain same? Okay, so total charge will also remain same. That means at any time t, if I draw the circuit, so then what I can say that this is the battery, and let us say the charge coming from this capacitor, on this capacitor, let us say this charge is plus Q and this is minus Q. And the 2C capacitance will get the some amount of charge such that the total charge will remain CE by 2. So on this particular plate, the charge should be equals to CE by 2 minus Q, and on this plate there should be CE by 2 plus Q, minus CE by 2 plus Q. So let us say this is the charge that is on the positive plate. This is the charge on the positive plate. Now there is also the resistance is there, the R resistance is there. Okay. Now if I move along the loop, so that the potential difference will be equals to 0. If I apply the Kirchhoff's rule, then the net potential difference will be 0. So if I move along the loop in this direction, I am moving. So there is a potential drop across this battery because I am moving from negative, potential gain because I am moving from negative to positive. Then across this I am moving, so across the resistance there is a current. So I is flowing, and because of that there is a potential drop. Again similarly the potential drop will be observed in the capacitor 1 and the capacitor 2. So the equation can be written as E, there is a gain, minus Q by C minus or plus C by 2 minus Q by 2C should be equal to 0. Okay. So this is the, I am applying the loop law for the entire circuit. So from this what I can get that the final charge that is there inside the capacitor, small q, can be calculated. So if I simplify this number, so small q comes to be as 5 by 6. Small q is equals to 5 by 6 times C into E. So this is the final charge on the capacitor C. On the capacitor C. So now, initially the capacitor having a charge of CE by 2. Now the final charge become 5 by 6 CE. So I can write what is the net charge increase. Okay. So delta Q increase for this situation. So delta Q for the capacitance C can be written as a Q final minus Q initial. That is equals to 5 by 6 CE minus what is our CE by 2. That is the initial charge. So that can be written as equals to CE by 3. CE by 3. So this is the total charge gained by the capacitor C. So now as a function of time t, I can write it is equals to Q should be equal to, so Q should be equals to Q initial plus delta Q, that's gain in charge, into 1 minus e to the power minus t by R into C. That kind of number. Now what is R? R is the equivalent resistance of the circuit, and what is C? C is the equivalent capacitance. Okay. Now in this situation, this 3 and 2C, this C should be the C equivalent number. And what is that number? That should be equal to C into 2C divided by C plus 2C. That means it is equals to 2C by 3. 2C by 3. Okay, that is the C equivalent. So corresponding to that, and only one single R is there. So can I write this should be equal to Q initial. Q initial is how much? CE by 2. CE by 2 plus delta Q, I got it as CE by 3. CE by 3 into 1 minus e to the power minus t. T is the any time t divided by RC. So ultimately we got 3t by 2RC. Okay. So that is the Q at any time t for the capacitor of capacitance C. So if I want to write the same logic for the, let us say I want to write the same variation for the 2C capacitor. So for 2C capacitor, initially there is no charge. For 2C capacitor, initially there is no charge. So what is the final charge on the capacitor? That is the delta Q part. So what you can write, Q value for the 2C component, that should be equals to Q initial. This Q initial number is 0 plus delta Q. What is delta Q then for this capacitor? That is equals to what this number? CE by 2 minus 2. Okay. So I have got it, Q is equal to 5 by 6 CE. So CE by 2. So I am writing it over here. So that is again 1 minus e to the power minus t by RC. So again the R will be R and C will be is equal to 2C by 3. So 2C by 3. So I can use that. Only thing is that the QY number should be 0 for this situation. And what about the delta Q? Delta Q should be equals to CE by 2 minus small q, that is 5 by 6 CE. Okay. So from this equation, I can calculate the value of delta Q. So corresponding to that, I can calculate what is the answer for this. Okay. So hope you understand this. Thanks for watching the video. If you like it, please subscribe also my channel. Thanks for watching and bye.